We are from Team PLCW. Today we would like to present our project. The title of project is Steam Power Pulley System. This is our project table of content. It includes group introduction, system introduction, group activity, demonstration and explanation, student comment. First is our group introduction. Our team member have me, Bang Ji Heng, and Lok Ka Seng, Chu Yong Hao, and Wong Kai Sen. The task distribution for Bang Ji Heng, which is me, is the team leader, collect recyclable component from project, coordinate team on project activity. The second is Lok Ka Seng, create slide for presentation, assist in making of project model, provide component for project. The third is Chu Yong Hao, identifying the reliability of the component, creating symmetric diagram, assembling component of model. The last is Wong Kai Sian, provide project idea and doing the proposal for the project. Provide ideas for improvement of model, bring tools for creating model.
Next, system introductions. So there are four basic concepts. The first concept is pressure. Pressure is a force exerted over an area, which is P equals F over A. Hence, the pressure from the tank can create a force over the turbine blade area. The second concept is energy. Energy is the capacity of the system to do work, which is the energy balance equation shown below. E equals KE plus PE plus U. The third concept is volume, which is the physical space inside the tank that the gas occupies. And lastly, work, which is the output of the system, which is force applied over a distance. Next, there are three principles used in this project. The first is Newton's third law. When high velocity gas strikes the turbine blades, it exerts a force through two main mechanisms, namely impulse, where the gas impacts the blade and pushes them forward, and reaction, where the air-force-shaped blade create a pressure difference as the gas flows over them, generating a lifting force that rotates the shaft. The second principle is the ideal gas law. The gas stored in the tank represents potential energy in the form of pressure. This is governed by the ideal gas law, PV equals nRT. In a high pressure tank, the gas molecules are tightly packed. When the valve opens, the pressure difference between the tank and the ambient environment creates a force that accelerates the gas toward the turbine. And finally, the Bernoulli principle. As the gas flows through a nozzle toward the turbine blade, it undergoes adiabatic expansion. According to the Bernoulli principle, as the pressure of the gas drops, its velocity increases significantly. The enthalpy of the gas is converted into kinetic energy. Because the gas expands so quickly, it usually doesn't have time to absorb heat from the surrounding, causing the gas temperature to drop sharply.
So next is the group activities. First of all, we done our proposal, and the proposal is basically talking about when the water inside the pot is heat to its boiling point, it produces steam. Because the pot is sealed except for the small outlet tube, the steam becomes trapped inside, causing the internal pressure to rise. As more steam is generated, the pressure forces the steam to flow rapidly through the small tube. This high-pressure steam is directly onto a small turbine, causing it to rotate. The turbine shares the same shaft as a drum. As a turbine spins, the drum rotates as well, winding up the strings that is connected to the pulley system. As the drum pulls the strings tightly, the effective length of the string decreases, which leaves the load attached on the another end of the pulley system. So first of all, we done our group discussion. We discuss and collecting the material needed for this project, and then we assembly and and do some improvements of the proposed model. Next is model development. First of all, we create a collector using aluminum coil to make the airflow streamline smoother. and then we assemble the tank and make sure no gas is leaking during the boiling. And we conduct the experiment. We testing the initial idea of the project, and then we face multiple issues such as the small blade area, the high friction on the turbine shaft, and the plastic heat tolerance. As you can see as the video shown, the plastic is basically melting because the casing cannot withstand the heat and soften due to the plastic have a heat tolerance of 60 degrees Celsius.
Next part is demonstration and explanation. There are some two demonstration you can see in the video. The first one is the upper part of the aluminum can. And the second load is the eraser. So these two are two different load with the different weight. And now is the explanation. At the first product, a minor container is used as the water tank to fill the boiler water and accumulate the steam. There is the hole with transparent tube to allow the steam flow outward to push the turbine effectively. The turbine was made by aluminum that has high temperature tolerance to prevent it from being melted. The turbine was connected with a rope that attached to the load. As the steam accumulating in the container becomes high, it produces a high output pressure to rotate the turbine, indirectly lifting up the load. In this project, top part of an aluminum can and rubber were used as load to show the time difference required to lift them up. And this is the result in a graph for the weight of the upper part of can is 3 gram, while the eraser weight is 10 gram. And the taken time for load to move approximately is 18 cm. So you can see in the graph that is shown.
Next is the calculation for the project. So we can use W equals mg to calculate the weight of the object, which is 0.0981 Newton for the eraser and 0.0294 for the cut can. The resultant force on the string can be calculated with the data taken during the project, which is F equals to ma, which is string tension minus the weight because the load is moving up. Thus, the tension force acting on the string, theoretically assuming no friction, would be the same as the weight of the load. Using P equals F over A with the area of turbine blade being 48 centimeters square, the pressure applied onto the turbine can be calculated. For the upper part of the can, we use the kinematic equation for constant acceleration. The acceleration would be 0.04 meter per second square. So the pressure would be 0.025 Pascal, and for eraser, the pressure would be 0.0469 Pascal. So these are the pressure required of the steam to push the turbine and create such force onto the pulley. And then for the modifications, for the turbine casing, we change from enclosed to open turbine, so there is no need for casing. And then the blade size, we change from 8 centimeters square to 48 centimeters square blades. The shaft is equipped with a metal piece on the side to reduce friction with the string and the box. And lastly, the pulley system, we simplified the pulley to reduce friction on the rollers so that there it's easier for the turbine to spin and move the load. And then lastly, for students' comment, I think that this project is useful for us to apply some application of the thermodynamic subject into real life. so that we can test our physical knowledge.
Next, my comment is this project is basically pretty challenging because we need to use recycling component where it's pretty hard for us to get some recycled items can handle more than 100 degrees Celsius, but it's for me it's pretty good for our experience overall.
And for my student comment, actually this project is dangerous because it could require large volume of steam which it could be explosion occurs. So it should be undergoing in a lab to provide a safety situation.
For me, the experiment can help students gain practical experiment, but the steam is too hot, so there is a high risk of scaling during the experiment. So this is our project presentation, and thank you.